right, so this researcher here thinks that boys and girls would be the same height on average prior to puberty. So the theory would be that hormones sort of, when puberty kicks in, make the boys grow taller than the girls, and that's why there ends up being a difference by the time there's adulthood, right? But prior to puberty, that there wouldn't be a significant difference. So it's an interesting theory, and maybe it makes sense. What we have to do is see if it's supported by the data. So what they say here is that 58 randomly selected boys of age 8 had an average height of this with a variance of this. Notice they talk about variance here. They don't give us a standard deviation here, they give us the variance. And then they say that 55 randomly selected girls have an average height of this with, again, a variance of 119 centimeters. Find the 99% confidence interval for the true mean difference. So we're asked to find the 99% confidence interval. And again, it's for the true mean difference between boys and girls' heights at age 8, and they ask us if there's a significant difference. So let's do our first step, which is to record the data for the problem. So whenever you're doing a confidence interval, you should record the data. So let's do girls and boys, and it doesn't matter what order you do the subtraction. So you can do boys or girls. Actually, here we had boys first, so I should have listed boys first. So let's go ahead and do that. I'm going to go ahead and start over and use boys as our first population. Again, it doesn't matter which way you do the subtraction, but let's just be consistent with what the problem had there. So we'll go ahead and use boys first. Okay, so let's start the writing over again, and we'll start with boys and then girls. Okay, so for boys, the sample size in the problem was 58. And the the sample mean for the boys is 123.5 centimeters with a variance of, so notice the notation, variance is s squared, right, of 98 centimeters. And for the girls, we have a sample size of 55, right, 55 girls. They had an average height of 126.1 centimeters with a variance of 119. Again, variance is s squared, so 119 centimeters for that. The confidence level is 99%, and the alpha is 0.01. So there's our list of values, boys and girls. All right, now the next step is to get our critical table value. So in this case, I'm going to get z alpha divided by 2. Why? Because the sample sizes are both large. So remember, first step, get the data. Second step, the critical table value. So let's go to the t-table, because this number can be found on the t-table. We're going to be looking at 0.01. Since it's in two tails, we will divide that in half. So we divide the alpha in half. So 0.01 divided in half is going to be looking up 0.005. We're going to look it up all the way at the bottom of the table where we have the large values. Once we do that, we'll come back and finish the problem. Okay, so we're looking at the t.005 column here. We want to go down to where it says large at the bottom, get the last digit, last number, because we're looking for a z value on the t-table. And when we do that, we find that the answer is 2.576. Okay, so we found our critical value to be 2.576. That's for the alpha of 0.01 and two tails. Now our next step is to get the margin of error. So remember, the formula for margin of error is z alpha divided by 2. Then we have the square root of sigma for the first population squared over n1 plus sigma for the second population squared over n2. Now remember, sigma squared is the population variance technically. We have sample variance, so we'll use sample variance as a substitute. And since it's already squared here, we don't have to square it. So we're going to go ahead and use, as a substitute, 2.576 times the square root of. For these values, we'll just use 98 over 58. And again, I don't have to square because it's already squared here, right? Plus 119 over 55. So be very careful when you see that they give you the variance. And remember, you don't have to square it now because it's given already squared. All right, let's take that now and calculate that, see what it ends up giving us. So we're going to end up getting 2.576 times the square root of 98 divided by 58 plus 119 divided by 55. And again, you don't have to put any special parentheses or anything, just enter it in as you would naturally do so. and you end up with the answer 5.056 ... right? I'm going to store that as a variable so I can come back and use it later, but that's our margin of error. Now, our next step, of course, is to do the difference x bar 1 minus x bar 2. And from that, we will subtract the error. Then we do the same thing again, x bar 1 minus x bar 2, but we add the error. Okay, that gives us our interval. So let's see what the difference is when we subtract these two numbers, right? So we'll do 123.5 minus 126.1. We'll get an answer of negative 2.6. That's the initial difference, negative 2.6. So we'll do that minus the error and negative 2.6 plus the error. So I just subtracted those x bars and got negative 2.6. Notice what that indicates. The girls were actually a little taller than the boys, right? At this age group, the boys and the girls were actually, they were close to the same height, but the girls were actually bigger than the boys. Okay, so from there, let's go ahead and finish the problem by subtracting off the error and adding the error. So I'm going to take that minus 2.6 value, and I'm going to subtract off the error. That's going to give me negative 7.66 centimeters. And I'll do the same thing again, but I will add the error this time. So negative 2.6 plus the error, and I get 2.46. Now, once I have that, I look at those two numbers and I have to interpret them, right? And what I see here is that 0 is within the interval. Of course, we're going to say that we are 99% confident, all of that stuff. We are 99% confident that the true mean for boys minus mean for girls is between, and then, these two numbers, right? The number negative 7.66 centimeters and 2.46 centimeters. But what that implies is that when we come down to answer this question that was asked in the problem, which is there a significant difference between boys and girls' heights at age 8? The answer we're going to come up with is no, there is not a significant difference. So there is not a significant difference. And the reason why there's not a significant difference is because 0 is in the interval. Right? 0 is inside the interval. So what we're saying is that the true mean difference between the average boy height and girl height could be 0. And if it's 0 at that point, you would be saying there's no difference between their average heights. And so essentially, because it's a candidate for the true mean difference, we can't say there's a significant difference between boys and girls. So the researcher may be right. He may be right that prior to puberty, boys and girls are the same height. And that's it. That's the end of the problem.